simplifying rational expressions is what we're going to work on again today. We did some like this yesterday, so you should know how to do this. You have to look at each factor kind of separately. The 2 and the 18, those are common, and they have a common factor of 2, so divide them both by 2. This one turns into a 1, and this one turns into 9. And then the x's, look at those together. X squared divided by x. X, so the x is gone from the bottom, and that turns to just an x on the top. And what about the y's? Y to the power of 4 on the bottom. So the y to the power of 3 cancels, but then there's 4 left down there. And we end up with, on the top, 1x, so just x, and on the bottom, 9 y to the power of 4. So all we're doing is simplifying these today. So here's another one that we're going to simplify. What do you think about that one? 3x over x times 2x minus 3. Can you simplify that? What's a factor that's common in the numerator and the denominator? X, right, so we can get rid of the x's. And then we have 3 over 2x minus 3. Is there a common factor now in the numerator and the denominator? The 3. The 3 is not a factor of the denominator. It's just one term of the denominator. So the only factors in the denominator are 1 and 2x minus 3. So there's not a common factor. So that one's actually done. Except we need to consider the non-permissible values, which we didn't do in the first one. But we're going to have that as part of our answer, what x cannot equal. 3 over 2. Anything else? 0. Why?
No, they can equal 0.
0's not always there, but 0 is there for this one. Because if you look back to the original question, it had a factor of x in the denominator. So you have to think back, when you're looking at non-permissible values, you have to go back to the original question and look at the factors there. So the original question had a factor of x in the denominator and a factor of 2x minus 3, which makes the non-permissible values 0 and 3 over 2. Here's another one that we're going to simplify. 16x squared minus 9y squared over 8x minus 6y. We need to factor the numerator and the denominator. Now, when we have more than one term, that's what you need to do. So this numerator, to factor it, we can think of it as 16x squared plus 0xy minus 9y squared. It's a trinomial, right? It's just that that middle term is 0. Then you could use decomposition on it and factor it. Try that. The thing about factoring this numerator, actually, like you can do this decomposition with that, but if you recognize it as a difference of squares, that's something you should kind of keep your eye out for, where it's a perfect square minus a perfect square. A shortcut for factoring that, take the square root of the first term, so 16x squared, the square root of that is 4x, plus the square root of the last term, 9y squared, the square root of that is 3y, and then the same thing but with a negative, 4x minus 3y. That's a difference of squares. If you actually think back to the last unit with radicals, it kind of might remind you of that whole thing with the conjugate where there's no middle term. Anyway, that's a good one to know, a good shortcut to know, is the difference of squares shortcut. And then when I factor the denominator here, I'm just taking out a 2, and I get 4x minus 3y. So now I can simplify it. But that's the key with these questions. When there's more than one term in either the numerator or the denominator, you have to factor first. Okay, so to simplify a rational expression that has more than one term in the numerator or the denominator or both, factor the numerator and the denominator. And then look for common factors in the numerator and the denominator that can cancel out. And what do you see here that can cancel? 4x minus 3y. That whole term, that whole factor can go. And we get 4x plus 3y over 2. The non-permissible value here is kind of strange though. You need to take the non-permissible values from the factored form, so don't look at the bottom because the bottom looks like it's fine. That's why we need to list those non-permissible values, because it looks like here there aren't any because it's just a 2 on the bottom. So that's never going to equal 0. But if you go up a level, there are variables there, so it could possibly equal 0. So we need to include that. And this looks like x cannot equal, anybody know?
Cannot equal 3 when y equals 4.
Or 3y over 4. Let's look at simplifying this one. B squared plus 2b minus 24 over 2b squared minus 72. What's the first thing you're going to do? Step 1. Factor. Factor the top and factor the bottom. So when I factor the numerator, I get b plus 6 times b minus 4. And the denominator, I took out a common factor. If you can take out a common factor, you should always do that. That should be the first thing you look for when you're factoring. So I took out a 2, but the denominator is actually not yet fully factored. This is another difference of squares, b squared minus 36, perfect square minus perfect square. So this now factors b plus 6, b minus 4, and then on the bottom 2, b plus 6, b minus 6. I'm using that difference of squares shortcut. Square root of the first term plus the square root of the second term, and then the square root of the first term minus the square root of the second term. You don't have to use the shortcut though, but you have to be able to get to there. And then we can get rid of common factors. So what's common? B plus 6. So b minus 4 over 2 times b minus 6 is the answer. There's nothing else common. Even though there's a b in the numerator and a b in the denominator, it's not a common factor because they're terms, not factors, things that are added or subtracted, not things that are multiplied. So we're done, but we need the non-permissible values. What can b not equal? 6. Anything else?
0. No.
0 is okay.
Because if it's 6 minus 7, 2 times 0.
Remember, it's things that'll make the denominator equal to 0. And it's not things that'll make the final denominator equal to 0. It's things that'll make the original denominator equal to 0. Or actually, we don't look up there at the original, we look at the factored form. So what's the other non-permissible value? We have 6, that comes from here, negative 6 from there. You have to find those non-permissible values from the factored form. So I'm actually just going to go plus minus. B cannot equal positive or negative 6. All right, here's the last one that I want you to try to simplify. X minus 4 over 4 minus x. I put this one in here specifically because questions like this show up all the time. And if you're working in your textbook writers love this kind of question. So I thought we should probably do one. We are going to factor the denominator. I'm going to leave the numerator as is, as an x minus 4. But when you look at the denominator, I'm going to remove a common factor. But first, I think I'm just going to switch it around because we're used to seeing the x first, right? And then the number. So can I write that the denominator as negative x plus 4? Is that the same thing?
Yes.
Yeah. Now can you see what the common factor is?
4.
That I can take out from the denominator? What can I remove as a common factor in the denominator? Any ideas?
1.
Negative 1. Yep. So I'm going to go x minus 4 over negative 1 times what? What will that become?
X minus 4.
X minus 4.
X plus 4.
No minus, because it's 4 divided by negative 1.
Yeah.
Right? We're taking a negative 1 out of that. So now what's the common factor? X minus 4.
Aha.
And our answer is, what's left on the top? Not 0, 1. And on the bottom? And what's 1 over negative 1? Negative 1. So this thing actually simplifies to negative 1. But non-permissible value, what can x not equal? 4.